Hi, my name is Izar. I'm a debug solution engineer, and today we're going to talk about Verisium Debug, focusing on System Verilog UVM interactive debug. So what is it all about? We have three pillars. First and foremost, the integration on top of Xcelium. This allows us to place breakpoints on the code, and from the point we get to it, step by step, go over the source code. Of course, this allows us to place forces and deposit while simulation is running. Second pillar is UVM understanding. We understand the UVM components and the dynamic objects in our hierarchy and have dedicated UVM tools aimed at solving specific debug problems of UVM. And lastly, we have randomization debug. We leverage the constraint solver steps to get insight on the debug of randomization. So let's go over an interactive flow just to understand how each of the tools is synced to the others. We start with the UVM error in our smart log. And by pressing this line in the smart log, we get connected to the source code that generated it, in this case, a UVM error message. We can see all the global and local variables of the scope, and we see the stack at the lower right-hand side. I could press on this hierarchy to get connected to the full hierarchy tree and see the instance in my full UVM hierarchy and understand the agents, monitors, drivers, and sequencers in my hierarchy, as well as dynamic objects in the variable screen. I'm connected to XMSIM, allowing me to run to a specific point in time and, more importantly, understand the UVM phases. So in this example, we see that we're running to the end of elaboration or build phase in any specific simulation. We have dedicated tools for specific UVM debug needs. First example is a sequence viewer, allowing me to understand which sequence is running from which sequencer or virtual sequence at any point of time. The configuration viewer allows me to connect a UVM config set in the source code to any get from any of the other source codes, be it implicit or explicit. And lastly, we have the UVM register viewer, allowing me to connect any UVM reg item to the entire register map space. With randomization debug, we leverage constraint solver steps and get insight on each and every step it took for solving a randomization. In this example, we see a failed randomization. We see all the local variables that took part in this randomization. And more importantly, on the right-hand side, we see a generated screen with all the constraints from different files and lines, all put in one place for ease of debug. So what are the main takeaways? We get an insight to the UVM environment, understanding the different components and objects in our design. We have native integration with Xcelium, giving us the capability of placing breakpoints and running, forcing, and depositing. And of course, we have strong randomization capabilities, leveraging the constraint solver and understanding the debug steps it took. If you want any more information, you feel free to contact us or the local AE team and get a full demo. Thank you.